Welcome to the Fish Husbandry talk for the Aquaculture in the Classroom 2023 workshop for teachers and extension agents and extension specialists. My name is Cassiano. I'm going to briefly discuss fish husbandry, mostly as it pertains to school systems. This is a very broad topic, so we're going to try to keep it as simple as possible, just enough to be dangerous. So aquaculture, the cultivation of fish or fish farming. Basically, you guys are going to start with fingerlings, that's the goal, and end up with an adult. The model species that I'm going to use for this talk, because most of you are probably going to use this species of fish, is tilapia or blue tilapia, blue Nile hybrid anyway. Going to take about 9 months to get to, a marketable size, or a size that you're going to desire. And if everything works out correctly, we're going to end up with that food. Start with a fingerling, grow it up, and then slice your fillet and feed it to your students or to other parents. Okay, so fish husbandry, basically we're just trying to create an advantageous environment for fish growth, and this entails a bunch of different aspects. But like I said, we're going to briefly cover this stuff. We have a whole water quality demonstration that we're going to go over. I'm also going to talk about fish density, some nutrition, biosecurity, and sanitation, and then really just overall water and air movement, just the environment that's within the tank itself. But these are techniques for keeping your fish alive and maintaining your recirculating aquaculture system. So like I said, there's going to be a whole demonstration about water quality. Water has a bunch of different components inside of it and parameters that we're interested in. Some of the parameters, we want them to be zero. We don't want to measure any total ammonia nitrogen, that's TAN, nitrite or CO2. We want to keep these as low as possible to zero. Other parameters like dissolved oxygen, total hardness, alkalinity, pH are going to fall within a range. And a lot of this really just depends on the fish species that you're growing. Some fish like a lower pH than others. And also the production phase. Most of you are going to be in what's called a grow out production phase, but sometimes breeding requires different parameters to be at different levels. And it's important for you guys to know that. So you are going to want to monitor your water quality routinely. I mean, ideally every day. I know that's a little unrealistic for producers and even teachers, but 1 to 2 times a week would be fantastic. Monday and Thursday, Tuesday and Friday, something like that. What you don't want to do is wait to see problems with the fish or problems with the system and then measure the water quality to see what's wrong. It's at that point in time, it's typically too late. Reduced performance from the fish is going to increase the stress on the fish, and anything that's stressed out is going to be susceptible to pathogens and reduced immunoresponse. So it's very important to be on top of water quality. There's also, a water quality parameter correlation, this sort of cascading effect, if you will, where one thing starts to go wrong, it leads to another parameter being off balance, and then another one goes off balance. And this is just very stressful for any organism and leads to a lot of pathogen and disease issues. So stocking density, the number of fish that are in your tank. Typically, you're going to go through a bunch of different sizes of tanks, not in a school setting, but in a commercial aquaculture production setting, you're going to have smaller tanks or smaller fry or larvae. And as they grow and get larger, you're going to transfer them. This is going to be saving labor, saving space, saves food, it saves money. But what you're going to do is you're going to stock your fry or your fingerlings directly into the grow out tank. So initially it's going to look very odd having a bunch of small little fish swimming around in a big tank. But this is really helpful because it's going to help allow your biofilter to become robust. You're not going to run into too many problems initially anyway. And then as the fish get bigger, you're going to start to reach that maximum carrying capacity. So that right when the biofilter can't handle that density anymore, you're going to be harvesting your fish. It's going to be, the timing's going to work out perfectly. If you're understocking, like I said, you're not using your resources wisely. It could encourage aggression, but like I said, it's going to be beneficial for schools. It allows you guys to sort of start slowly and build to that carrying capacity. If you're overstocking, you could have system issues. Your biofilter is not robust enough to handle it. It can stunt the growth of the fish. But more importantly, it's going to increase stress. It's going to be increased agitation. And, there's that word again, stress. We really want to avoid stressing the fish out. That's a way for them to lead to disease. This is with any animal. So usually when they get stressed out, then that's when they start to get sick. So for you guys specifically, this is the question that I get most often is, how many fish do I put in my tank? It's not a set number, but I'm going to give you a set number here in a second. But it's really in terms of weight and food, weight of the fish and the amount of food that you're feeding. It also depends on the fish species. So like I said, a lot of you are going to grow tilapia. Your suggested biomass is going to be about 1/4 pound per gallon. Your average size when you harvest is going to be 1 pound. Now keep in mind that's what we're targeting as far as the system's concerned, because at the end that's how big they're going to be, about 1 pound. So for a 200-gallon tank, we're going to put 50 tilapia fingerlings in there and let them grow and be big. Batch culture, if you want to try, you can take into account the volume of the other system components. Maybe there's more than 200 gallons. Maybe you want to push it. Maybe you want to be a cowboy and try a little harder. So yeah, maybe you could start with 100 if you're going to sample some through the duration of your production. Then maybe you want to try a little more. It also depends on the feeding schedule. So fish nutrition, there's a bunch of different commercial diets available. There's some for catfish, some for koi, tilapia, salmonids. There's a approximate composition listed on the feed bag. It talks about proteins, lipids, carbohydrates, vitamins, minerals, whatever. So if you're feeding, most of the school systems are catfish, koi, or tilapia. So there's diets specifically for those fish. It's going to sound intuitive, but smaller pellets for the smaller fish. Some of them are sinking, some of them are floating. They do have flakes and dusts and fines and even live feeds as well. But for you guys, you're going to primarily be focused on feeding them some sort of a pellet diet. Some schools get into growing duckweed for their tilapia as well. This is a fish that'll pretty much eat whatever you throw in the tank. But if you want them to grow fast, you're going to have a sort of high protein diet that's going to allow them to put on as much weight as they can. So how much? Fish are commonly fed, 1/2 to 1% of their body weight per day for 5 days a week. For growing tilapia, it could be 15 to 5% of body weight per day. You actually feed them less as they grow, but you end up feeding them more per volume. So, the cup that you're feeding them is going to have more and more food in it, but per body weight is going to be less as they get older. If you want to make it easy on yourself, a general rule of thumb is as much as they'll eat in 5 minutes. You could do this 1 to 3 times a day. Depends. Initially, I would start out slower than that, but near the end there, I wouldn't feed them a bunch past what they eat in 5 minutes. They really don't like food that's been waterlogged, and it'll sit there, and it's not good on the system itself to overfeed a tank in one big feeding. Feed conversion ratios, I suggest learning about this. This is the amount of feed given divided by the amount of weight gained on the animal. This is really important because this is about resources. Tilapia having a feed conversion ratio of about 1.5 to 1. To put this into perspective, cattle have somewhere around 6 to 1. So they take a lot more resources to add onto that 1 pound of meat. Chickens are very similar to tilapia, about 1.5 to 1. So we really want an animal that has a pretty low feed conversion ratio so that we're making a good use of our resources, i.e. the food. Food storage is super important. Food it's got fish meal in it, It's loaded with proteins. It's got tons of lipids, and they can become rancid very quickly. And you don't want this. Fungus can lead to diseases. And so, be mindful of the expiration date. Store it in a cool, dry place, not a refrigerator, because it's actually a little humid sometimes. So you want to use it very frequently within 3 months. We actually freeze ours. This is our food storage facility right here. It's cool and dry in a freezer, and it does extend the shelf life a little bit. Fish nutrition's super important. Some of those feeding rates, if you're underfeeding, they're not going to grow. They're going to starve. If you're overfeeding, you could have system issues, fat deposits. This is a big problem within schools, overfeeding. So you want to be mindful. The kids are going to want to feed the fish constantly. So just be careful that you're not overfeeding the system. The fish can get sick, and the system itself can not function properly. Improper. You want to also make sure that you're feeding them the right diet. It can lead to deformities and abnormalities, lack of growth, disease. And like I said, don't feed them rancid feed. It'll have fungus on it. It'll smell bad. This is definitely something that you do not want to do. The fish is going to have problems. All right, so you really want to follow good biosecurity and sanitation techniques. This is basically to prevent the spread of disease on your farm or at your school. You're going to have just the one system maybe to start, but eventually you may have other systems. Somebody's going to bring a fish in from home. They're going to want to put it in the system. They're going to put it in the tank. I really would advise against that. There's all sorts of bacterial communities that are on fish and on humans and on any animal. And so we really just want to make sure that we're preventing that sort of spread of disease or spread of bacteria. Clean your equipment, the nets, the buckets, the automatic feeders, whatever it is. You could use Virkon, which is a special disinfectant. Chlorine is good. 70% isopropyl alcohol is also very good. I would go right with 70%. Anything higher sort of evaporates too quickly to actually be effective. And then you just want to make sure that your system is running efficiently. Your components are functioning properly. You're going to have to remove the debris from your system. The fish, especially tilapia, are very dirty. And so you are going to have to siphon it, which is essentially like a water vacuum. But it's really just a good way to get some of that debris off the bottom. Don't want to let that sit in there for too long. You can manipulate the water and airflow a little bit, and that'll help clean the system and get that debris into your filtration components where it can be dealt with a little easier. But I don't know any tank that doesn't need to be cleaned at some point in time, especially tilapia. So you're going to want to limit your traffic. I know this is especially difficult at schools. Teachers and kids and visitors are always coming. The administration is going to want to show off the system to whoever comes to the school. So it's hard to limit the amount of visitors that come and the amount of kids that are going to want to see it. But you want to limit that as much as possible. Fish from other systems, like I said, guarantee you, especially there's always a kid that has a fish tank at home that wants to bring his pet fish from home. I seriously advise against this. And the tank location, think about this. One of the schools was wanting to put it in a very centrally located area. I also advise against this as well. You want to have as much, control over the location and the amount of stuff that's going into the water. I've seen kids throw pencils and pennies and all sorts of stuff into a fish tank, and it's really not good. It's a stressor on the fish, but it could also just hurt the system as well. So foot baths, schedules, any sort of barrier to keep people. You want to teach the kids, you want them to have access to it, but you want to have a time and a place for those types of activities. The water movement is super important, water and air movement, and this could make or break how the RAS systems, the recirculating aquaculture system components function. Your water and air inlet and outlet placement, you don't want the water inlet right by the drain, so that all that fresh water coming into the tank is going right down the drain. You want to make sure that the flow and the current in the tank is conducive to whatever fish that you're growing. A lot of this, can be different. Tilapia is a very forgiving species. So, some of you are going to want to create a circular flow, and that's going to make them move in one sort of school and move in one direction. But it really just depends on, what you want to accomplish in getting some of those other system components to function correctly. And by that, I mean, there's going to be debris in the water, and how the air and the water is moving is going to allow that debris to move to the filtration components, which is going to make it function better. And we're going to discuss this a lot at the workshop. Yeah, I've mentioned fish stress a few times. It's very important. We want to, not stress them out as much as we possibly can. The fish is unable to maintain a normal physiological state because of various factors adversely affecting its well-being. So we want to keep them happy. When they start to get stressed out, they start to get sick. What can cause a fish to become stressed? Well, a lot of different things, chemicals, the water quality, like we mentioned before, the diet composition. If you're feeding them something that they don't need, if it's too much lipids, they're going to get a fatty liver, and they're going to be uncomfortable. They're not going to be physiologically functioning. If their water quality is off, they're not going to be happy. And so these are some of the chemical stressors. Biological, it's going to be crowding. Near the end of their production phase, right before harvest, it's probably not going to be too crowded. Depends on how many you start with. It could also be aggression and other organisms that are in the water as well. The light, the sound. Sound is a big one, especially within the schools. Kids are always, loud and tapping on the tank. Try to reduce this as much as possible. That really stresses a fish out. And like I said, the increased stress is going to lead to an increased number of problems. And then just procedural stuff like moving them around, shipping them, disease treatments. If something were to happen, you're going to have to treat them with some sort of chemical, which is going to stress them out. And like I said, just overall moving them around, netting them up, moving them over, anything like that is going to cause stress in a fish. So that was a very basic fish husbandry discussion. Each one of these components, could be a 20 to 30 minute talk in itself. So this is kind of just an overview of some of the things to consider when you're talking about fish husbandry. You can reach out to either me or Katrina. I'm making the mistake there of giving you my cell number. So no, but use it. Get a hold of me. Let me know what's going on. That's a part of my employment. And so, don't be shy when it comes to issues that are going on within your tank, and don't wait until the last minute. Please reach out when it's necessary, early, and so that we're able to address these issues in a timely manner. All right, thank you very much for your time. We're going to discuss some of this stuff when you guys get to the workshop. All right, I'm looking forward to it. Enjoy.